So chapter 2 includes the vehicle dynamics and load emulation, which has been followed and executed throughout the experimental setup. A mathematical modeling has been done to find out the limitation of the braking force that can be applied during the traction and braking. Here, the braking torque, tractive limiting braking force, or the tractive limiting force can be calculated by equation 2.3, where the ground reactions has been used. Here in equation 2.3, we can see that the tractive limiting force depends upon the varying road slope, and also it depends upon the maximum motor capability and the maximum force that can be supported by the interaction of the tire and the ground. In this figure, we can see that the interaction of various forces when a vehicle is moving in the longitudinal direction with a rear wheel drive during uphill climb. So to find out the limiting braking force during the braking for the front as well as for the rear wheel, equation 2.6 and 2.7 has been used. So upon plotting these equations, like equation 2.3, 2.6 and 2.7, here in figure 2.2, for a developed driving profile around the IIT Mandi campus, we found that to execute this driving profile, the traction and braking torque is lesser than the 200 Newton meter at wheel, but the limitation is much higher. So the limitation is greater than 680 Newton meter for traction, and it is greater than 460 Newton meter for braking. So upon analyzing these braking tractive limitation as well as braking limitations, we found that this driving profile can be executed on the experimental setup. So this equation 2.9 has been used for executing or for implementing the slip speed control through induction motor, and corresponding equation 2.10 provides the slip speed that relates a particular load torque for a driving profile. In figure 2.3, a schematic diagram of experimental setup has been shown, where IPMSM is the traction motor powered through this lithium ion battery and connected to this low voltage high current voltage source inverter. This traction motor is mechanically coupled to induction motor, which is being powered through the three-phase grid and controlled through the voltage source inverter and diode bridge rectifier. So these are the specifications of the experimental setup which has been used. That is specification of this three-wheeler IPMSM motor, induction motor, and the energy storage system, that is the lithium-ion battery, lead-acid battery, ultra capacitor, and for the bidirectional DC-DC converter. So this figure 2.4 shows the experimental setup, where this is the traction motor. This is the IPMSM motor which is acting as an traction motor, and it is being powered with the help of these batteries, either from the lead acid battery or the lithium battery for the respective research gap, and it is being controlled through this voltage source inverter. The second mechanically coupled motor, this is the induction motor, which is emulating the EV load. This motor is being controlled through the slip speed control, which is powered through this three-phase grid and controlled through a different voltage source inverter. This is the ultra capacitor connected to the DC link through this bidirectional DC-DC converter. The driving profile, loading profile, and all the control technique has been implemented through a DSP F28335 controller. This figure shows the driving profile developed around the campus of IIT Mandi, which includes speed profile, slope profile, torque, load torque requirement throughout this profile, as well as the slip speed that should be implemented through the induction motor to execute this load torque profile.